Okay, so you know how when you're prepping for these senior software engineer interviews, um, there are just certain topics that feel really make or break.
Oh, yeah, for sure.
And one that I keep hearing about over and over again and seems to trip a lot of people up is Lambda expressions in Java.
Yeah, it definitely comes up a lot.
Yeah, and it's not just about knowing the definition. It's like you really have to understand it at a deeper level to impress interviewers at that senior stage.
Right, it's about showing you can actually use them effectively, not just that you've seen the term in a textbook.
Exactly.
Yeah.
So that's what we're diving into today. Lambda expressions, what they are, why they matter in Java, and how understanding them can really help you shine in those senior level interviews.
Sounds good.
Okay, so let's start with the basics. If you had to explain a Lambda expression to, let's say, another engineer prepping for interviews who maybe hasn't worked with them a ton, how would you break it down in simple terms?
Well, I'd probably say something like, imagine you have a little chunk of code, a little mini function that you want to use in different places, or maybe pass around to other parts of your program.
Okay.
A Lambda expression is basically a way to do that. It lets you write that code in a really concise way without having to create a whole separate named class for it.
So it's like packaging up that behavior almost like it's a piece of data itself.
Yeah, exactly. It's like treating code as data, which is a key idea in functional programming. And that's one of the reasons Lambdas are so powerful in Java. They bring in more of that functional style, which can lead to cleaner, more readable, and more expressive code.
Right, and that's something senior engineers are definitely expected to be comfortable with. Now, can you give some specific examples of where you'd actually use Lambda expressions in Java? Like what kind of problems do they help solve that would impress an interviewer?
Sure, so one class example is sorting. Let's say you have a list of objects and you want to sort them in a custom way. In the past, you'd have to create a separate class that implements the comparator interface and define the comparison logic in a method. But with Lambdas, you can do all of that right in line with the sorting code. It's much more concise.
Makes sense.
Another area is concurrent programming. Lambdas make it so much easier to define tasks that you want to run in separate threads, especially with all the functional interfaces in the java.util.concurrent package.
Right.
And then you have things like event handling in user interfaces or working with streams and collections. Lambdas let you define the behavior for those events or stream operations really cleanly right where you need them.
So it's all about making the code more concise and readable and really focusing on the behavior you want to express.
That's it. And that clarity is especially important at the senior level where you're often dealing with more complex systems and you need to make sure your code is maintainable and understandable by others.
Now, one thing that's always fascinated me is that Java has always been so object-oriented. Everything's a class, everything's an object. So how did Lambda expressions even fit into that picture? It seems almost like a shift in thinking.
Well, it is and it isn't. Java is still fundamentally object-oriented, but lambdas were introduced to kind of address some of the verbosity that comes with that approach.
Okay.
Before lambdas, even for simple functions, you'd often have to create anonymous inner classes, which could be a lot of code for a small piece of behavior.
Yeah, I remember those days. Not very fun.
Exactly. Lambdas provide a much more streamlined syntax for creating these function-like objects. So they bridge the gap between object-oriented and functional programming styles in a way.
So it's not about abandoning object-oriented programming, but about adding more flexibility and expressiveness.
Exactly. And that's a big part of what senior level development is all about, having the right tools to write the best possible code for the situation.
Okay, so we've talked about what Lambda expressions are and why they were added to Java. Now let's get into the nitty-gritty. What does the actual syntax look like? What should people be prepared to write in an interview setting?
All right, so the basic structure is pretty straightforward. You have parentheses for the parameters, an arrow, and then the body of the lambda. It can either be a single expression or a block of statements.
Okay, so let's say I want to write a Lambda that takes two numbers and adds them together.
Okay, so that would be something like int x, int y, nsx plus y.
Pretty simple, right?
Yeah, that's the beauty of it. It's concise and easy to read. You can see at a glance what the lambda is doing.
And that arrow is like the key visual element that tells you you're dealing with a Lambda.
Exactly. It separates the parameters from the body of the lambda.
Now, I've always been curious about the term Lambda itself. I know it comes from somewhere in math, but I've never fully understood the connection. Is that something worth knowing for an interview, or is it just trivia?
It's definitely worth knowing. It shows you have a deeper understanding of where the concept comes from. The term lambda originates from lambda calculus, which is a system in mathematical logic for expressing computation. And it was developed by a mathematician named Alonzo Church. He used the Greek letter lambda, which looks like an upside-down V, to represent anonymous functions.
Ah, so that's where the term and the arrow symbol come from.
Interesting. Yep. And while you probably don't need to go deep into lambda calculus for an interview, knowing this connection shows you're not just memorizing syntax, you're actually interested in the underlying concepts.
That's a good point. It demonstrates a more well-rounded understanding.
Hmm.
Okay, back to the syntax. What if you need a lambda to do something more complex than just a single expression? Like what if you need multiple statements or loops or something?
Then you just use curly braces to enclose the body of the lambda, just like you would with a regular method. And if you need to return value, you use an explicit return statement.
So it's basically like writing a mini method within the lambda.
Exactly. It gives you the flexibility to express more complex logic.
Got it. Now, what about lambdas that don't take any parameters? What does the syntax look like for those?
For those, you simply use empty parentheses before the arrow. So it would be dinning it to try it to execute Langor.
Okay, empty parentheses, no arguments. Simple enough. Now, one thing I see a lot in Lambda examples is that the types of the parameters aren't always explicitly written out.
Right.
How does Java figure out what those types are if they're not specified?
That's where type inference comes in. The compiler is pretty smart. It can often figure out the types of the parameters based on the context.
Okay.
For example, if you're using a Lambda with an interface that expects specific parameter types, the compiler can infer those types from the interface.
So if I'm using a Lambda with a comparator, which expects 2 strings, the compiler knows that the parameters to the Lambda should also be strings.
Exactly. And this can make the code even more concise because you don't have to repeat the type information.
Definitely. Now, what about if there's only one parameter? Does the syntax change at all?
Yeah, if there's only one parameter and the type can be inferred, you can actually omit the parentheses around the parameter name as well.
Oh, interesting. So it can get even shorter.
Exactly. It's all about writing the most concise and readable code possible.
Okay, so we've talked about parameters. What about the return type of a Lambda? Do you ever have to specify that explicitly?
Nope. The return type is always inferred by the compiler. It looks at the body of the Lambda and figures out what type of value it returns.
So if I have a Lambda that just returns an integer, the compiler will know that the return type is int.
Exactly. And it makes sure that the inferred return type is compatible with what's expected by the interface or method where you're using the Lambda.
Got it. The compiler is doing a lot of work behind the scenes to make things easier for us. Now, you've mentioned interfaces a few times, specifically functional interfaces. Can you explain what those are and why they're so important for understanding Lambdas?
Sure. A functional interface is an interface that has exactly one abstract method. That's the key definition.
One abstract method.
Yep. And Lambda expressions are essentially a way to provide the implementation for that single abstract method. When you write a Lambda, you're basically creating an anonymous implementation of a functional interface.
So when we use that Lambda with the comparator example, the comparator interface is the functional interface in that scenario.
Precisely. Comparator has that single compare method, which takes 2 objects and returns an integer indicating their order. And our Lambda provides the implementation for that compare method.
So it's like the functional interface defines the contract, the shape of the behavior, and the Lambda fills in the details of how that behavior actually works.
That's a great way to put it. And this connection between Lambdas and functional interfaces is really fundamental to how Lambdas work in Java.
Now, in some other languages, you can actually have variables that directly hold functions.
Sure.
Is that something you can do in Java? Or do functional interfaces kind of fill that role in a way?
That's a really insightful question. And you're right, Java doesn't have first-class functions in the same way that some other languages do.
Yeah.
But functional interfaces with Lambda expressions provide a mechanism that's conceptually similar. You can't declare a variable of type function directly, but you can declare a variable of a functional interface type and assign a Lambda to it.
So it's like you're storing the behavior defined by the Lambda in a variable that represents a specific type of function.
Exactly. And that lets you pass that behavior around and use it in different parts of your code, just like you would with a first-class function.
So you couldn't just assign a Lambda to a variable of type object then?
Nope. Object is the root of the class hierarchy in Java, but it's not a functional interface. It doesn't have that single abstract method that a Lambda can implement.
That makes sense. The compiler needs to know what kind of function the Lambda represents.
Exactly. It needs that target type, that functional interface, to connect the Lambda to a specific behavior.
Okay, cool. Can you give us another example of a common functional interface that people prepping for senior interviews should be familiar with?
Sure. One that comes up a lot is predicate. It represents a function that tests a condition on an object and returns a Boolean true or false.
Okay, I've seen that one before.
Yeah, it's used extensively with streams and collections for filtering and other operations. For example, you can use a predicate with the remove if method of array list to remove elements based on a certain condition.
So like if I have a list of strings and I want to remove all the empty strings, I could use a predicate that checks if a string is empty.
Exactly. And you could write that predicate using a Lambda expression like SSSempty. It's concise and easy to understand.
Much cleaner than writing a whole separate class for that.
Right. And that's the power of lambdas and functional interfaces. They let you express complex logic in a very concise and readable way.
Right, so we've covered a ton of ground here.
Yeah.
From the basic syntax and history of lambdas to their relationship with functional interfaces and how type inference works. For someone getting ready for those tough senior level interviews, what would you say are the absolute key takeaways about lambdas?
I'd say the most important things to understand are, first, that lambda expressions provide a compact way to represent behavior that you can pass around and use in different parts of your code. Second, you need to really grasp the concept of functional interfaces, those interfaces with a single abstract method that serve as the target types for lambdas. That connection is crucial.
Right.
And third, make sure you're comfortable with how type inference works in lambdas, how the compiler figures out the types of parameters and return values based on the context.
So basically understanding the what, the why, and the how. What lambdas are, why they exist, and how they actually work in Java.
Exactly. And being able to explain those concepts clearly and give relevant examples will show interviewers that you have a deep understanding of modern Java and functional programming, which is essential at the senior level.
Right. It's not just about memorizing syntax. It's about showing you can actually apply these concepts to solve real-world problems.
Exactly. And being able to discuss the benefits of using lambdas like reduced boilerplate, improved readability, and the ability to write more functional style code will really make you stand out.
Absolutely. So as you continue your interview prep, I'd encourage you to think beyond just the mechanics of lambdas. Consider how this idea of treating code as data, which is facilitated by lambdas and functional interfaces, impacts the design of larger systems.
Good point.
Think about scenarios you've encountered where using this approach might lead to more flexible, maintainable, or testable code. That kind of higher-level thinking is what really demonstrates a senior-level understanding and can lead to really interesting discussions in your interviews.
That's great advice. Showing that you can think about the broader implications of these features and how they fit into the bigger picture is super valuable.
Awesome. Well, I think that wraps up our deep dive into Lambda expressions in Java. Hopefully, this has given you a solid foundation and a boost of confidence as you tackle those senior-level interviews. Best of luck out there.
Thanks for having me.
And to everyone listening, thanks for joining us on the deep dive.